I'm gonna add extra pixels on the border of the given image. So now the dimension is 7 by 7. Then I'm gonna use 3 by 3 filter or 3 by 3 kernel. Look, if you remember, from here up to here, this was my given image. This was my given image, which was 5 by 5, if you remember. I pick exactly the last image with the same pixel. From here up to here, we have 5 by 5 pixel. To do padding, I add extra layer of the pixels on the borders, all the borders of the matrix, which means that add extra column on the left, extra column on the right, an extra row on the top and then on the bottom with all the zero values. Don't forget, you have to pick all the zero values for the border pixels. These are the new border pixel values for the input image. Why I'm doing this? I'm doing this to preserve the image. Now, if you remember last time in a stride, we were taking this 3 by 3 matrix with a kernel, and then we leave this column, then pick this one, and then leave the second column, then pick this one, which means that this border column, this first column, comes once in a stride, like just only once, and then for the second time you leave it, the second column comes twice, and the third column comes thrice. But the first column comes only once. So there's a problem. There's a problem, which means that you are missing some information. You are missing some pixels here of the input image. Now, to preserve all this information, what I'm going to do, I'm using padding process. So with the help of the padding process, this column will come twice. So all these columns will come multiple times, which means that you will not skip a single information of the input image if you do padding. So therefore we are using extra pixels with the zero values on the border. Look, the kernel of the filter is 3 by 3. So we're going to apply 3 by 3 matrix here. Therefore I'm going to pick 3 by 3 matrix here from 7 by 7 image. So let me do exactly the same process what we were doing so far for the stride. Take the product which equals to 23. Look at here, we are using 3 by 3 kernel here. You can call it kernel or filter, it is up to you. Kernel and filter is one thing. Therefore, if it is 3 by 3, you have to pick 3 by 3 matrix here from 7 by 7 matrix of the image. Then take a product. So 0 times 0 plus 0 times 1 plus 0 times 0 plus 0 times 3 plus 1 times 2 plus 0 times 1 plus 3 times 3 plus 6 times 2. So when you do the product, when you do the multiplication and then addition process, at the end you will get 23 value here. We are building featured map. If we apply 3 by 3 matrix, if we apply 3 by 3 kernel on the 7 by 7 image, my original image was 5 by 5, if you remember, 5 by 5. But then when I add the border pixels with the zero values, it became 7 by 7 now. So it is 7 by 7 now. So if it is 7 by 7 and we are applying 3 by 3 kernel, your featured map will be 5 by 5. Because we are trying to retrieve exactly the same input image. We are trying to preserve all the features of the input image. Input image was 5 by 5. So we need 5 by 5 featured map as well. This will be the new version of the input image with all the features available here. That's why we are doing padding. We are applying stride 1 here. So leave the first column and pick this matrix 3 by 3. Take the product, you will get 33 value. Look at here, just take the product of this matrix with the kernel. 0 times 0 plus 0 times 1 plus 0 times 0 plus 1 times 0 plus 1 times 3 plus 0 times 2 plus 9 times 1 plus 3 times 1 plus 6 times 3 plus 0 times 2. So 0 times 0 plus 0 times 1 plus 0 times 0 plus 1 times 3 plus 0 times 2 plus 9 times 1 plus 3 times 1 plus 6 times 3 plus 0 times 2. It equals to 33. 33. So there we got the second pixel of the featured map. Then leave the second column and pick this 3 by 3 matrix. Take the product with the kernel, you will get finally 27 value. This is the third pixel of the featured map. Look, 0 times 0 plus 0 times 1, 0 times 1 plus 0 times 0 plus 0 times 3 plus 9 times 2 plus 3 times 1 plus 6 times 1 plus 0 times 3 plus 0 times 2. Do all the multiplications and additions. It returns 27 value. This is the third value of the featured map, third pixel of the featured map. Now leave the third column and pick this 3 by 3 matrix. Again, take a product with the kernel. You will get this fourth value, which is 43. 0 times 0 plus 0 times 1 plus 0 times 0 plus 9 times 3 plus 3 times 2 plus 0 times 1 plus 0 times 3 plus 5 times 2. So 0 times 0 plus 0 times 1 plus 0 times 0 plus 9 times 3 plus 3 times 2 plus 0 times 1 plus 0 times 1 plus 0 times 3 plus 5 times 2 equals to 43, which is the fourth value of the featured map. And then pick this matrix, 3 by 3 matrix, and take product with the kernel. You will get this 24 value. Look at here, 0 times 0 plus 0 times 1, 0 times 1 plus 0 times 0 plus 3 times 3 plus 0 times 2 plus 0 times 1, 0 times 1 plus 5 times 3 plus 0 times 2, 0 times 2. Do multiplications and additions, you will get 24, which is the fifth pixel value. So there we got all the values of the first row. Now look at here, all the columns and all the rows of the original image has been covered 2 times. So they have been covered equally now. They have been covered equally. Therefore, we can say that we have reserved all the information. If you remember, because of these extra border values, we started from here, Remember, my original image is from here up to here. It is 5 by 5. These are the extra border values. When you pick this matrix, these 4 values came out of the process, and then leave the first column, started from here. This column came second time, and also this one second time, this one first time, these two second times, this one first time, and then leave the second column as well, started from here. Again, this value came 3 times here. This is 2 times, this is 1 time. And then leave the third column, started from here. Now this column came 3 times, this is 2 times, this is 1 time, and then started from here. This came 3 times, this came 2 times, this came 1 time. All the elements came more than 1 time. If you remember last time, when you pick only this 5 by 5 image, which is my original image, when you started from here, 3 by 3 matrix, and then leave the first column, you will pick this one. So this first came 1 time, this is second time, and then when you pick this one, this will came third time, this is second time, and this is first time. So this column and this column will came only once. This will be second time, this will be third time, this will be second time, this will be first time. So the border column, the border values will be covered once. And then similarly, when you go down, the border row will cover 1 time. So when you cover the border value 1 time, and the rest multiple times, it means that you are missing some information. You are missing some information here in the original image. And that's the reason we are using padding. We are adding extra pixel layer on the borders. And when you do so, this border value of the original image, this is my original image. So this border value will come 2 times, 3 times, 3 times, 3 times, 2 times. When you do padding here, so multiple times, all the pixels of the original image will be covered, which means that we will reserve all the informations of the original image, and we will get a featured map with the same dimension 5 by 5. Remember, my original image dimension is from here. From here up to here, it is 5 by 5. So we'll get exactly the same 5 by 5 dimension of the featured map, which is the new version. It is the new version of the original image with all the existed featured in the image. You are going to reserve all the features with the help of the padding. Now once you reach here, then you have to start from here. Repeat exactly the same process. Take this 3 by 3 matrix and take a product with a kernel which is 3 by 3. Do solution. Solve it further, you will get 34 value, which is the 6th pixel point of the featured map. Look, 0 times 0, 0 times 0, plus 1 times 1, 1 times 1 plus 0 times 0, 0 times 0 plus 0 times 3, 0 times 3 plus 3 times 2, 3 times 2 plus 6 times 1, 6 times 1 plus 0 times 1, 0 times 1 plus 5 times 3, 5 times 3 plus 3 times 2. So when you simplify this expression, do all the products and all the additions, at the end you will get 34 value. This is the 6th pixel point of the featured map. When you take the product of this pixel 3 by 3 with a 3 by 3 kernel, it is a simple product. You must know how to take the product of the matrix. Then if the border value and pick this 3 by 3 matrix, take the product with the kernel, at the end you will get 51 value. Look, stride equals to 1. Therefore when you reach here at this point, then you have to go down only one row, only one row. Therefore I went down here only one row. Started from here with a 34 value, and then this one, and then this one, and then this, and then this. So 1 times 0, 1 times 0 plus 0 times 1, 0 times 1 plus 9 times 0, 9 times 0 plus 3 times 3, 3 times 3 plus 6 times 2, 6 times 2 plus 0 times 1, 0 times 1 plus 5 times 1, 5 times 1 plus 3 times 3 plus 8 times 2. Do further simplification, at the end you will get 51 value. The value is 51 here now. Now to pick this one, take a product with a kernel which is 3 by 3. At the end you will get 58 value. Look at here, 0 times 0 plus 9 times 1 plus 3 times 0 plus 6 times 3, 6 times 3 plus 0 times 2, 0 times 2 plus 0 times 1 plus 3 times 1, 3 times 1 plus 8 times 3 plus 2 times 2. Do all the multiplications and additions, you will get 58 value. Then leave the third column and pick this 3 by 3 matrix. Take the product with the kernel, you will get 22 value. Look, 9 times 0 plus 3 times 1 plus 0 times 0 plus 0 times 3 plus 0 times 2 plus 5 times 1 plus 8 times 1 plus 2 times 3 plus 0 times 2. If you simplify this expression, you will get 22 value. So this is the 9 pixel value here. And then leave the fourth column, pick this 3 by 3 matrix, take the product with the kernel, you will get 12 value. 3 times 0, 3 times 0 plus 0 times 1, 0 times 1 plus 0 times 0, 0 times 0 plus 0 times 3, 0 times 3 plus 5 times 2, 5 times 2 plus 0 times 1, 0 times 1 plus 2 times 1, 2 times 1 here plus 0 times 3, 0 times 3 plus 0 times 2, 0 times 2. When you simplify this expression, do all the multiplications and addition process, at the end you will get 12 value. This is the 8th pixel point of the featured map. So we are on the way to get all the values, all the pixel values of the featured map. Once you reach to this point, then leave the second row and start it from here. again 3 by 3 matrix with a 3 by 3 kernel. Take the product with the kernel, you will get this 29 value. Look, 0 times 0 plus 3 times 1, 3 times 1 plus 6 times 0, 6 times 0 plus 0 times 3, 0 times 3 plus 5 times 2, 5 times 2 plus 3 times 1, 3 times 1 plus 0 times 1, 0 times 1 plus 1 times 3, 1 times 3 plus 5 times 2, 5 times 2. When you simplify this, you will get 29 value. Then leave the border column and pick this 3 by 3 matrix. Take the product with the kernel, you will get this 65 value. 3 times 0 plus 6 times 1, 6 times 1 plus 0 times 0, 0 times 0 plus 5 times 3 plus 3 times 2 plus 8 times 1 plus 1 times 1 plus 5 times 3 plus 7 times 2. It equals to 65. Then leave the second column and pick this 3 by 3 matrix. Take its product with the kernel. You will get 71 value. Again, it is a simple product with the kernel. 6 times 0 plus 0 times 1 plus 0 times 0 plus 3 times 3 plus 8 times 2 plus 2 times 1 plus 5 times 1 plus 7 times 3 plus 9 times 2. It equals to 71. Then leave the third column and pick this matrix, 3 by 3 matrix, and take its product with a 3 by 3 kernel. At the end you will get 76 value. Look, 0 times 0 plus 0 times 1 plus 5 times 0 plus 8 times 3 plus 2 times 2 plus 0 times 1 plus 7 times 1 plus 9 times 3 plus 7 times 2. Do further simplification, do all the multiplications and additions. At the end you will get 76 value. Then leave the fourth column and pick this 3 by 3 matrix. Take its product with the kernel. You will get 41 value. Again, it is a simple product. 0 times 0 plus 5 times 1 plus 0 times 0 plus 2 times 3, 2 times 3 plus 0 times 2 plus 0 times 1 plus 9 times 1 plus 7 times 3 plus 0 times 2. It equals to 41. And then leave the third row and start it from here. Take the product with the kernel, you will get 40 value. 0 times 0 plus 5 times 1, 5 times 1 plus 3 times 0 plus 0 times 3 plus 1 times 2 plus 5 times 1 plus 0 times 1 plus 4 times 3 plus 8 times 2. If you simplify this expression with all the multiplications and additions, you will get 40 value. Then leave the first column and pick this 3 by 3 matrix. Take its product with the kernel. You will get 55 value. Look, 5 times 0 plus 3 times 1 plus 8 times 0 plus 1 times 3 plus 5 times 2 plus 7 times 1 plus 4 times 1 plus 8 times 3 plus 2 times 2. It equals to 55. Then leave the second column, pick this 3 by 3 matrix. Take this product with the kernel. You will get 64 value. Look, 3 times 0 plus 8 times 1 plus 2 times 0 plus 5 times 3 plus 7 times 2 plus 9 times 1 plus 8 times 1 plus 2 times 3 plus 2 times 2. It equals to 64. Then leave the third column and pick this 3 by 3 matrix. Take its product with the kernel to get 56 value. 8 times 3, 2 times 1, 0 times 0, 7 times 3, 9 times 2, 7 times 1, 2 times 1, 2 times 3, 0 times 2. It equals to 56. Then leave the fourth column and pick this 3 by 3 matrix. Take its product with the kernel to get 43. Look, 2 times 0, 0 times 1, 0 times 0, 9 times 3, 7 times 2, 0 times 1, 2 times 1, 0 times 3, 0 times 2. It equals to 43. Once you reach to this point, then leave the fourth row and start it from here. Take its product with the kernel to get 17 here. Look, 0 times 0 plus 1 times 1 plus 5 times 0 plus 0 times 3 plus 4 times 2 plus 8 times 1 plus 0 times 1 plus 0 times 3 plus 0 times 2. When you do further simplification, do all the additions and multiplications, you will get 17 value here. Now leave the first column and pick this 3 by 3 matrix. Take its product with the kernel to get 35 value. Look, 1 times 0 plus 5 times 1 plus 7 times 0 plus 4 times 3 plus 8 times 2 plus 2 times 1 plus 0 times 1 plus 0 times 3 plus 0 times 2. It equals to 35. Then leave the second column and pick this 3 by 3 matrix. Take its product with the kernel to get 37 value. Look, 5 times 0 plus 7 times 1 plus 9 times 0 plus 8 times 3 plus 2 times 2 plus 2 times 1 plus 0 times 1 plus 0 times 3 plus 0 times 2. It equals to 37 value. Now leave the third column and pick this 3 by 3 matrix. Take its product with the kernel. You will get 19 value. So it is 7 times 0 plus 9 times 1 plus 7 times 0 plus 2 times 3 plus 2 times 2 plus 0 times 1 plus 0 times 1 plus 0 times 3 plus 0 times 2. It equals to 19. Then leave the fourth column and pick this 3 by 3 matrix. Take its product with the kernel to get 13 value, which is 9 times 0 plus 7 times 1 plus 0 times 0 plus 2 times 3 plus 0 times 2 plus 0 times 1 plus 0 times 1 plus 0 times 3 plus 0 times 2. So there we got all the pixels of the featured map. We got the featured map with the dimension of 5 by 5, which is exactly the dimension of the given image. If you remember, my original image is from here up to here, which is 5 by 5. It means 5 rows and 5 columns, 5 by 5. Exactly the same thing, exactly the same dimension we got here in the featured map. This featured map is the new version of the given image, of the input image. This is the new version. So since both of them have same dimension, the featured map and the input image, they have same dimension, 5 by 5 and 5 by 5. I repeat it, I'm not talking about 7 by 7. 7 by 7 is this whole complete matrix with extra pixels on the border. I'm talking about the original image, which starts from here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So 5 rows and 5 columns. its dimension is 5 by 5. The dimension of the featured map is also 5 by 5. So I can say that we have reserved all the features of the input image. And that's what we do in the padding. If you remember last time in the stride, the dimension was 3 by 3. So from 5 by 5, we transformed into 3 by 3. From high dimension, we went to the lower dimension with the help of the stride without padding. But since we apply padding here, we apply extra pixels layer with the 0 values on bottom of the matrix of the given image. Therefore, we got 5 by 5 featured map. Now the reason is that when you skip the border values, the border 0 values of the pixel, for example, if you pick this 3 by 3 matrix, this first column will come only once. Similarly, this first row will come only once. We took one extra pixels on the border. Therefore, we're going to pick this 3 by 3 matrix here, and then we will pick this here. So it came twice, and then this, it came 3 times. This 3 times, this 3 times, this is 2 times. So this column and this column will come more than 1 time. Once you reach at this point, here, then leave the first row and start it from here, 3 by 3 matrix, then leave first column, 3 by 3 matrix, and then 3 by 3 matrix, and then again 3 by 3 matrix, and then this 3 by 3 matrix. Don't forget, take the product of this 3 by 3 matrix with the kernel, with the filter 3 by 3 matrix. Take the product, you will get these different pixel values, which we call featured map. Similarly here, when you reach at this point, then leave the second row and start it from here, and then leave the first column, start it from here, and then leave the second column, then leave the third column, then leave the fourth column here. Once you reach at this point, then leave the third row and start it from here, 3 by 3 matrix, and then leave the first column, 3 by 3 matrix, 3 by 3 matrix, again 3 by 3 matrix, and then 3 by 3 matrix. Once you reach again at this point, leave the fourth row and start it from here, 3 by 3 matrix, then the first column, 3 by 3 matrix, and then 3 by 3 matrix, 3 by 3 matrix, 3 by 3 matrix. It depends on the stride value. If the stride value is 1, then you have to leave 1 column and 1 row, 1 column and 1 row. If stride equals to 2, then you need to leave 2 rows and 2 columns, 2 rows and 2 columns. This symmetrical movement of the filter, 3 by 3 filter or kernel, is called stride. But this extra layer of the pixels on the border with the 0 values is called padding. We do padding. So to reserve all the feature of the input image, you need the same dimension of the featured map what you have for the input image. If you remember, for the input we had 5 by 5. This is my input image. So the same 5 by 5 dimension we got in the featured map, which is the new version of the input image, with the same features, with all the reserved features of the input image. I hope it is very clear now that what is padding, what is stride, why we need padding. We need padding to reserve all the features. If you want all the features of the input image, for example, if you think that I don't want to skip any feature of the input image, suppose there is a situation, there's a project in convolutional neural network in CNN. You don't want to skip any feature. You don't want to miss any feature. Then you need to apply the padding process. That's why we need padding. Now normally what we do in CNN, we reduce the dimension of the input image to save the time, to save the memory consumption, to save the processing cost. The processing cost will be low if you have lower dimension, to make it faster. And that's the reason we are applying kernel trick in CNN to reduce the dimension, as we did last time. From 5 by 5 we came to 3 by 3 in the featured map. But there might be some situation in CNN you don't want to miss any feature. So to extract all the features of the input image, you need padding, which is in the featured map. So I hope the point is clear now. But there is a mathematical formula. You can apply that formula before doing all this process. You will know the dimension of the featured map with the help of this mathematical formula, which is output equals to image size minus kernel size plus 2 times padding all over stride plus 1. It equals to 5 minus 3 plus 2 times 1 all over 1 plus 1, it equals to 5. This 5 means 5 by 5 dimension. 5 by 5 dimension of the featured map. It is a mathematical formula for the padding. Output equals to image size minus kernel size plus 2 times padding all over stride plus 1. Image size, the original image size is 5 by 5. Don't forget, my original size of the image is not 7 by 7. 7 by 7 is because of the extra pixel values that I've added here on the border. My original image size is from here up to here, which is 5 by 5. So I'm going to put 5 here for the image size, and the kernel size, the kernel or the filter size is 3. It is 3 by 3. Therefore, I will put 3 here plus 2 times padding. Padding equals to 1. Why? Because I have added one layer of pixels on the border. One layer of pixels, which means that one row and one column. If padding equals to 2, sometimes you may need the value of the padding equals to 2. If padding equals to 2, it means that you have to add two layers of the 0 on the border. For example, 2 rows, the one layer of 0 here, and then here, and then here, and then here. So you have to add 2 rows and 2 columns to the input image in case if padding equals to 2. But since I choose padding equals to 1, therefore I have added only a single layer of 0 on the border, which means that 1 row and 1 column. What is stride? Stride equals to 1. As we saw here, that we were moving ahead only a single column, a single row, a single column, a single row, a single column, a single row. Why? Because I took stride equals to 1. If you take stride equals to 2, then you have to move ahead 2 columns and 2 rows, 2 columns and 2 rows. So stride equals to 1, padding equals to 1 plus 1. 5 minus 3 is 2, 2 times 1 is 2, so 2 plus 2 will be 4. 4 all over 1 is 4 plus 1 equals to 5. There we got the dimension of the featured map. If you want to know the dimension of the featured map before doing all this stride operation, if you just want to know the dimension of the featured map, then you can simply apply this mathematical formula. It will give you the dimension of the featured map in the future. Before doing all this process, if you apply this mathematical formula, or sometimes you may be confused that whether my dimension is true or not. If you want to clarify it, you simply apply this formula. If it matches with the featured map, then you are on the right track.